Okay. Now let's look at this example. Just now there are two equations you learn. If it's series, then Rs equal to R1 bracket R2 and so on. Another one, if it's parallel or you have a backup system, then Rs equal to 1 minus bracket 1 minus R1 bracket 1 minus R2 and continue. Okay, so as you can see on the slide here, you know that in mathematics we have a certain priority we need to solve first before we proceed to the next steps. For example, you do multiplication first, then you add, then you do the addition or subtraction. Same with this one. This kind of question, what you do the parallel case first. You solve the parallel case first. So in this case, you have this one. So the strategy is to solve the parallel first. So this one you have 0.92 and 0.0. So what is the parallel system reliability? 0.9942. Okay. By using the parallel equation, so I'm not going deep into this one. So again, if you see the system, it will be like the mathematics priority. So you give the priority to parallel first. You do the parallel component first. You calculate that one. Then you substitute, not substitute, but then you substitute back into series systems. Okay, so this is 0.98. Now multiply 0.992 and multiply 0.98. So what is the system reliability for this case? 0.95. Now you check your calculation. You have to take 0.98 multiply by 0.992 multiply by 0.98. Okay, let's check the answer. But important is you understand the concept, because the value will change in the exam. Of course, in the exam, it won't be this simple. It will be very complex systems. But again, priority give to the parallel first. You do solve parallel system. Now, what happens if the system is 3-1? I'll give you another one. Maybe I'll extend this one another one. So same. You do the parallel system first. If it's 3 or 4, then you do one more, bracket 1 minus R3 and so on. Okay. And because some student you give 2, you can do, you give 3, cannot do it, or give 4, cannot do it. Yeah. So you solve the system. The first one you will get this equation. So actually you simplify the diagram as this one. Then 0.98, 0.99, 0.98, you'll get 0.51. Okay. Any question for this example? Okay, we go for a more challenging one. Very lengthy. It just gives you a statement. Then you try to solve. This kind of will be like your final exam kind of standard, or maybe your test 2 kind of standard. Okay, so you read the statement. Or those you can download from the Canvas tutorial version 2, chapter 7. It's quite a lot of pages. I think 35 pages of that. But you can download if you have tablets or something. You can go and download it. Okay. So this company, Jack, is a producer, supervisor of this company. Is committed to the company new quality effort. So you do want to do something, improve the products or make new products or new services. But the program encourages making products component in-house to ensure high quality levels and instill work pride. So what is the objective of the program? Is to what is the earlier intention is that they want to make the part component in-house. The system seems to be working well. One assembly, it requires reliability of 95%. It's normally purchased from a local supplier. So now you have one component which is 95%. This one from your supplier. Now it is being assembled in-house from 3 components that each blast a reliability of 0.96%. So you have 2. There are 3 questions, three scenarios. First one, they receive a customer complaint for the past 3 months since McCormick started doing its own assembly work. Can you explain why? Okay, there are 2 scenarios. One is the assembly in-house, and then this customer complaint. Okay, the next question. What level of component reliability is necessary to restore the product to its former level of equality? So this one you need to do a little bit of rearrangement of the equation. Third one, Jack can't increase reliability of the individual component. However, he can get a backup with the reliability of 90% to each component. If the backup have a reliability of 0.9% or 90%, how many will be needed to achieve 0.95 reliability of the assembly? Okay, so it's kind of a higher ranking, a higher rank of thinking already. So you need to, just now it's very direct, so that one is normal thinking, but now it's you need a higher, because you're doing degree. So this kind of question is designed for degree kind of level. Okay, the previous tutorial question, that one is a certificate or diploma level. So when it comes to degree, you see this kind of attempt. Okay, so you know that you have 2 kinds of you can either do series or parallel, right? So the first cases is ask you why customer complain for the last 3 months when this owner, the producer supervisor doing their his own assembly work. Okay, so you use the first series, means you assume that the production was combined 3 component with 96 program. This one is, it tell you already. So now it's being assembled in-house with 3 components that each give you 96%. This is built in-house component. So what you assume is that when you build in-house, you have a series system where you build 3 components together. So because now it tell you in the statement here, in the question here, it say in-house by using 3 components. So the starting point is that you build a series system, and then you give it to customer. You sell it out to customers. So what is the reliability? Is 0.885, which is 88%. That's why you receive customer complaint. Because in your advertisement, everything, you say our product works more than 90%. 90% works. But now you receive customer complaint. Why? Because of your system reliability. The way you assemble it, it gives you problem already. Okay. So this complaint is valid because your reliability dropped. Why? Your individual component is 96%. But now when you assemble it, you sell it to customers, customer only get 89% reliability. So of course complain. Okay. Next question. What level of component reliability is necessary to restore the product to its former level of equality? So you know that series equation is R1, R2, R3, and so on. So now you need to reverse the equation. You use if because you have three component so R1 multiplied by 3 exponential 3. Then you move the exponential from one side to another side, you get a cube root. Make sense, huh? So now you need to know which one is system, which one is the individual component. So the question asks you, what level of component reliability is necessary to restore the product to its former level of equalities? So you put in 95 on the left-hand side, then the rest is the solution. How you know it's 95? From the question. It tells you one assembly which require a reliability of 95%. 95 is the total assembly. Try to catch the word correctly. So it gives you in-house component, each give you 96. Here, one assembly, it gives you 0.95. Yeah. So you have to know which one is RS, which one is R1, R2, R3. So from this equation, you can calculate reliability of that individual parts. So the answer will be 0.93 reliability, so that the overall system, when you assembly later, will reach 95%. Because now the objective, you need to get assembly of 95%. You need to get this one. The question asks you, what is the reliability of these three component, individual one, means R1, R1, R1. What is the RS if you use R1 component? So you already have RS, which is 95% from the question. So you want to find individual component that you need to keep, you need to buy or install to keep 95% efficiency or reliability. Make sense, huh? So you try to understand the language or how the question asks you. Now the third one is more on the creativity, more on the innovation part, a higher level thinking on it. Okay. Now the third question is that he can't increase the reliability of individual component. Individual component is 96%. So just now in the previous example, we already see that if you do parallel, it can increase to 99% from 95% or something, right? The previous example. So the case 3 is that he cannot increase the individual component. He can add a backup with a reliability of 90% to each component. Means what does it mean? Means there's the original component, put in a backup. This backup is 90%. So it tell you how many backup system you need to increase the system, to increase the system reliabilities. So if the backup have reliability 90%, how many will be needed to achieve 95% reliability of the assembly? Do you understand the question? Now it gives you the backup reliability. You know that the original system, the assembly, it have to be 3 R1, 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 or R2. R1, R2 in this case is the same. Okay, so it's R1, R1, R1. Now now the owner want to increase the efficiency by studying how many backups you need. What I mean by backup? This is one backup, 2 backup, 3 backup. How many set he need to do so that he get 95%? You need to do 3 calculations. Because earlier you already calculated the original one, the R1, R2, R3, R1, R1 you already calculated already. So the original is that. So you use that as your base, then you add 1, you see how many, like the tutorial question you do just now. You add 1, then you calculate, you get 1 number. Add another 1, you calculate the same, parallel, then combine become series, you get 1 number. You do 3, parallel, you do parallel calculation, 3 set of parallel calculation, become series, you multiply the numbers again, you get 1 numbers. Then you look at 3 numbers. Which one is reach 95% in this case? Okay, I just show you, understand the concept. Okay, so I show you this one is the original one, 96%, 96, original one. This one get customer complaint. So you want to increase the reliabilities, right? So you do the first set. You have 1 backup. Okay. Yeah. The question tell you the backup have a reliability of so and so. So when you add backup, backup is 0.9. So 1 set of backup, you do 1 set of backup, you do the parallel calculation. Of course, this equation might be confusing to you, but again, you do the one that I show you, this one. Okay, the one that you see on the screen here might be confusing, but you use back 1 minus bracket something. With this one, you still get the same answer. So if you use the original 0.96 with 1 backup with 0.9, if you use the parallel equation, you arrive at 0.996. Although it seems the arrangement is a bit different from the general equation. Right? You get 0.996, right? Right. Agree with the mathematics calculation first. Okay. Now you know that 1 backup give you that one. So means you combine this one, you get 1 component is 0.996. Then you do calculation. Okay, you do calculation, means you pull this one, put inside here, means 1 backup system. 0.96, this one is 0.996, 0 is 0.96. So that's why the reliable system is R1 plus R2. R2 is your parallel system, multiplied by the R3. You multiply the 3 reliability, you get 0.918. It is 92%, about 92%. Okay. Is this enough to meet the objective? No. So you know that first backup is not. So you do 1 more. Do the same. Because you know that 1 pair of parallel is 0.996. Of course, you can ask, hey, sir, can I put my backup in second one or not? Can. Why? Because the equation is still the same. Because R1 multiplied by R2 multiplied by R3 is still the same. Mathematically, no matter where you put it, it's still the same. So if you do 2 backups, the system reliability will become 0.952, 95%. So it fulfill, right? Then it tell you you can do 1 more, 3 backups. If 3 backups will give you the better number or not. So you do 1 more set. You do 3 backups. 3 backup means what? You take 0.996 multiply 3 times. Yeah lah. If you lazy to do, if this kind of question come out, you do 2 backup, then your answer is 2 backup is able to achieve the objective, then still correct. It's just that this is just additional step so that you have confidence. You have confidence. So this one, okay. So maybe, okay, in this case, because your backup have the same numbers, 0.90 ma. So what if the question, it give you two backup options? If the question give you two backups to use, backup 1, 0.9, backup 2, 0.88, only 2% different. So maybe the question will change a little bit. It will tell you if the system required 3 backups, what is the value that you need for your backups, for example? Okay, I do the same. You do the same, then you find the simultaneous equation. You solve the simultaneous equation. Yeah, but the concept is still the two equation, series and parallel. Then you will see the question got parallel one, you solve the parallel first. Then you combine the number, you do back the series calculation. Make sense, huh? Okay. So the answer is choose 2 backups rather than 3. Why 3? Why 3 backup is not the answer? Because it's more costly. And in terms of in terms of project management, it's not a good one. Of course, as a user, you want 99, 98% efficiency you want. But as a manufacturer, as a service provider, you want to keep it to minimum customer requirement. Okay. Okay. Already done with the reliability analysis. Next, we look at reliability have other name. We call it MTBF, which is mean time between failures. Means failure time. You can, this is a failure 1, failure 2. So within this time frame, MTBF is also reliability. Titanic. The Titanic broke down because of the material problems. Because that time they don't have material science discipline. So they just simply use the submarine. That one is to me, if you read the story, the CEO was stupid. Cannot stay stupid, but I think the feasible study is not enough. Yeah. Yeah. Maybe he's too rich. He like too rich. Yeah. No place to spend money. So yeah. Okay. So again, reliability have other name. It's called MTBF. So it's a length of time a product or services in operation before it fail. Another name is MTBF. So you will see this one when you use software to solve problems. Another word is called failure rate. Failure rate is another calculation. So what mean by failure rate? MTBF is a reciprocal of the failure rate, 1 over failure rate. This is the third equation for today. MTBF equal to 1 over failure rate. So what mean by failure rate? I'll give you an example. So if your laptop battery fail 4 times in 20 hours of operation, so the failure rate will be 4 divided by 20. It failed 4 times over 20 hours. So 4 divided by 20, so it's 0.2. So MTBF will be 1 over 0.2. Yeah. So MTBF, if you use the equation, it will be 1 over 2, it will be 5 hours. The unit for MTBF is in the unit that the problem state. In this case, because the question mentioned hours, so the MTBF is hours. Means the mean time between failures is 5 hours. Means every 5 hours, your battery will fail. By average, means the battery will fail every 5 hours. So when you open your laptop, means if this is a case, means the maximum time you can use the laptop is 5 hours. Okay. But nowadays our battery for laptop is very efficient. It can last for a days or 2 days, something like that. Okay. Yeah. Okay, third equation, MTBF equal to 1 over failure rate. Okay, these are the steps that can improve your reliability. So just now from the equation that we learned, you try to reduce component inside the design. Because the more component you have, it will reduce the reliabilities. Okay, so improve by all these things, simplify design, improve reliability of the individual component, because the equation you use R1, R2, R3. The third one, later we'll learn about manufacturing process. So if the product can be easier to manufacture, also improve the reliability, or easier to assembly, well maintained, or you train a user to use it, that also increase the reliabilities. So this one is more. That's why they give you user manual. That's why they give you car manual. They expect you to read actually. So when you claim insurance, they will ask you, do you read the manual or not? You don't read, that is your responsibility, because they already established the information to you. You are the one who do not read, so it's not their fault. Okay, so user manual actually is one of the strategies to protect their products. Okay, so the next term we learn for today is maintainability. That's not reliability, right? Now we learn maintainabilities. Maintainabilities or serviceabilities refers to the ease of cost which the product service is maintained or repaired. Means how easier it is maintained. We call maintainability. So if you're in IT or PC, nowadays you see all the PCs have lots of piece of components. This also for maintainabilities. Means if the memory broken, you just change memory. If the capacitor, one of the capacitor was gone or processor is gone, then you just change processor and so on. And so on. So this is example for maintainabilities. Okay. So another one is when you design something, make sure you focus. When it comes to functional design, try to identify what is the critical parts or critical location that always broke down. Okay. In fact, this critical location also how the company makes money. Why do I say that? If you observe products that launched for the previous 10 years, the lifetime is getting shorter and shorter. The things that you buy is more easier to broken. Why? It was designed in such a way so that there is a repeat sales. Last time, engineer was trained to design things that can last very long. But nowadays, with precision engineering, you design something that expect to broken at a certain time. It depends on products. So they will design something, but they don't tell the consumer. You design that part, it will fail at a certain frequency or certain time. For repeating sales. Okay. This is for in the business context. It's not about ethics or not. It's about sales and the survivability of the business. Okay. Okay, the rest you read. Let's read. Another one is mean time to repair, MMTR. Just now is mean time to failure. This is MMTR. So another equation for today, the fourth equation, cost system availability, SA. You take MTBF. MTBF is 1 over failure rate. Okay, so MMTR, mean time to repair, is given in the question. So you just plug in the value there by calculating SA, system ability, equal to MMTF divided by the total failure and repair. Yeah, SA equal to MTBF divided by MTBF plus MTTR. Okay, let's see example, how you apply this one. So an owner must choose a service provider for his company e-commerce site. Other factor being equal, he will base his decision on service availabilities. Means if you see the question like this, means it forces you to use the SA equation. Given the following service server performance data, which provider should he choose? So you have provider A with MTBF so and so hours, MTTR certain hours. So you have A, B, and C. So what is the answer for SA? You find lah. So each one of you, maybe one of you find A, find B, one to find C. For A. Okay, SA equal. Yeah. Okay, SP. That 99736. 94. Oh, okay. Then the third one. So which one you choose? Which one you choose? We have three numbers there. Which one you choose? You choose the higher one. Okay, so SA equal to MTBF divided by the total of MTBF plus MTTR. First one, you get 94%. Second one, you get 95%. Third one, you get 96%. In this case, you choose supplier C. Okay, because the service system availability is 96%. Means the system available for you to use is 96%. This one taken into account of break time, the failure times, and also the ease of repair. Because one it broke down, you need to repair, so you consider this component. Okay, this is a simple tutorial question. Another one high level question. So Amanda is trying to decide. I think this one is the same. So I just skip This one you understand, right? Okay, it's the same. So go very fast. So you get the three numbers there. So 0.95, 0.0, 95%, 90%, 93%. So which one you choose? You choose the highest one. Yeah, nothing complex. Okay, next is usability. Usability is easier to use. Easier to use. So there are few of point there. What is usability? Factor that affect the experience will be ease of learning, ease of use, ease of remember how to use, means the psychomotor memory, frequency of error, and user satisfaction with the experience. So these are the combination of factors that you need to consider when you discuss about usability. Okay. So a few examples. Apple, they are quite good in product designs. Okay, so all these you're quite familiar lah. iPod, iPads, phone, that's all. Okay, We have done with functional design. Now we go into production design. Now the word production means you go through a few process in the production flow. Right? Okay. Production design. So it's about the production process. So there is a statement mentioned when your design is difficult to make. Usually it will give you poor quality of products because you go through so many process and there's a lot of parameter you need to control. One screw up, everything screw up like that. Okay. Another one is maybe the engineer, they over design the products. They over design too many features, that some features that the customer not even think about it. Then you also want to add in something like that, option, parts, and so on, right? Or lack of knowledge of manufacturing also can affect your design, the quality of design. Okay, there are three terms that we need to learn under production design. It's called simplification, standardization, modularity, and design for manufacture. There are four things when it comes to production design. So the question might ask you how to improve production design. Means what are the approach that you can use to improve production design? These are the four answers. Simplified, standardization, modulation, and design for manufacture. Then the question might ask you to explain one of it. The answer is four. Simplification, standardization, modulation, design for manufacture, 4 marks. Explanation, maybe another 4 marks for that particular component. Okay, so this one is like a section A kind of question, right? Okay, 4, recommended approach for product design: simplification, standardization, modulation, and design for manufacture. Okay, the first one. What I mean by simplification? You make it simple. Simple by reducing number of parts, sub-assembly, and option for that products. You make it simple. So you elaborate about the simple words. It means you reduce the number of parts, reduce the number of sub-assembly, and options for the products. Another one is avoiding two separate fasteners and adjustment. Means if you have lots of things you need to assembly one, then is also you can simplify the process. We need more lights. Is it okay? Yeah. Okay, I'll give you one example. Simplification. So let's say you need to build tools, engineering tools like that. So it consists of one platform, two body, and then you screw it with fasteners. Then there's a handle on top of it. Right? So a company want to make a toolbox, something like this, for example. Okay. So this one, they want to increase the productivity by using automated assembly. They want to use robotics arm or a flow, a process to do this assembly, for example. Okay. Now, initial design is shown as this one. So you have a lot of screw, a lot of holes, handles, and so on. So how do you apply simplification? Okay, how do you apply simplification? Okay. So again, if this kind of question come out, you don't need to draw exactly like this. You just need to explain what you understand about this one. Okay, you can just simplify this one and then you explain. Okay, so the initial, you have 24 common parts, including the nuts and all this. And you need 48 seconds to assembly the whole things. Because the company want to see whether they can use automated system to assembly this part. So this is the prototype they have, the first version. Now they apply the simplification parts. So although this design was not complex, but it might be complex for a robot to assembly. The robot arm have to go here, go there, and so on. What they do in second step is that they simplify the design. What I mean by simplify, you reduce the component, sub-assembly, and other things. You refer to the definition just now. Okay. So now they simplify the toolbox by eliminating the fasteners. So you as an engineer, if you have civil design, how you, if the chief engineer say, I want to remove the fastener, how you design? How you design? You want to remove all the fasteners. How you design? If you are this is the case lah. The chief engineer asks you, hey, you go home, your homework. Tomorrow give me one design that remove all the fasteners. What you can do? If the chief engineer want you to apply simplification procedure or approach, how are you going to do it? He say, I want to remove fasteners. Huh? Stepping. Snap. How do you do snap? Okay. Yeah, that is one of the things. Another one? How will you do it? Okay. Consider one piece, right? Means you remove all the fasteners. The shape is still there. I mean, the general shape is still there. Now you want to remove the fasteners. What else you can do? Welding. Okay. Welding. Or any magnetic things that you can do, right? You put in magnet or something so that catch the things, right? Or a certain design that you can slot in, snap and catch, something like that. Like origami lah. If you play origami or Lego, can snap like that. Okay. So this is an example. So it make into one piece. The body, the lower body, it make into one piece. So it remove totally the assembly you need to do, screwing and all this. Okay. So this you make into one piece base and so on. So now they only need to consider the top part and replace this one with the insert. That's just to secure the handle. They managed to reduce it to 12 seconds, from 84 seconds to 12 seconds. Okay. Next, they further study whether this one I can still do further simplification. Okay. So of course, the second design, they can do 43 assembly in one go, but now they increase 43. The first design 43 in 1 hour. The second design they can do 300 assembly. This one 300 sets in 1 hour. So they increase the productivity. The third one, the third version is that. Third version, you see, it removed the plastics, the plastic snaps. It used slot. Means they change this body into flexible material. Then they just just put it in like that. Just bend it and then put it in. Then they stretch like a spring mechanism like that. Okay. So with this, you only need 4 seconds to assemble the thing. You just push the thing in, then snap. Okay. This is simplification example. Okay. So it reduced from many parts into 2 parts only, 2 main parts. The body and the handle just slot in. Okay. One quick motion, and you only need one motion to do it. Just push the thing in, rather than screw and all this. And they can do 900 assembly in 1 hour, from 48 into 900, quite a lot. And the one good thing is that because earlier they want to use robotic arms, at the end it's too simple. They decided no need robots. Okay, no need automation at all for this design. Yes. It's just that the setting, the background setting is that the owner want to purchase a robotic system for this design. Then they go back to the engineering team, the engineering apply the simplification approach. Then at the end, they found that for this prototype, they actually don't need to buy a robotic system. They just pay someone just to press it, or a machine just to one motion like that. Just put in there, slot, put in like that. Okay. So simplification sometimes it can help you to reduce a loss of cost and increase the production. The second method, we have 4 approach. Just now for simplification. The third one, the second one is standardization. Standardization means you use commonly available and interchangeable parts. For example, what is standardization? Yeah, so the keyword there is interchangeable. Interchangeable. So what I mean by if you have standardization, these are all the benefit. High volume, low investment in inventory, and so on. Okay, this one you read. Okay, I'll just give you one example. What are the interchangeable parts? Light bulbs, all these light bulbs, batteries, all these are interchangeable parts. Okay, application of standardization means you use all these interchangeable parts, because when you interchangeable part, you can mix a lot of things. I give you I think 2 examples. Okay, this one is standardization. So all these are battery. The third one is more on modular. Modular design means you have a standardized building blocks, modules, and unique finished products. Nowadays in construction, they already use precast. You know what is precast, right? Precast component, molding, and all this. Traditional building a house, you need bricks and all this. Nowadays they bought the wall. They call it Lego. The wall or module. They just fix and then just put in the cement at a certain corner or pump in the resin. Then that's it. So this is called module design or modular design. They combine all the standard blocks together. It's like Lego bricks like that. So one example is automotive. Like for example, Toyota. They share the same body chassis for their Camry, Corolla, Lexus model. Okay. This is one of the modular design. Okay. Another one, you know Campbell, right? Very famous, soup. How they do this modular design approach? They start with 4 basic broths: beef, chicken, tomato, seafood. They produce 125 variety by combining different secret recipe from the factory. They only need to produce 4 broth. They mix according to ratio. They become 125 products. Means you start with something simple, but you mix, become another. Okay. Your printer, your ink printer also another modular design. You have 3 colors, only 3 colors, right? Basic color. Then by using the inkjet ink combination, you can print very colorful picture. That is also modular design. Okay. Design for manufacturing. Okay, this one in other terms in production design. So design for manufacturing, we call it DFM. You design a product so that it can be produced easily and economically. Okay, what are the example that, for example, this diagram. So you have all the standard parts. You don't only, like for example, this is on the precision metal stamping. So you have all the stamper, the stamp. So you have different shape. So if you want to have a certain shape, you just change the module. Just take out this one and change. Okay. So DFM, design for manufacture, is a process where you can produce it very fast by changing one of the process. Okay. So these are the benefit. You just read. There are two benefit: improve quality, reduce time of process. I think I have example. Okay, so guidelines. When you use DFM, these are the guidelines. Go and read. You minimize the parts, avoid fasteners, you do standard parts, and then one parts used for many use, and then very easy to assembly. This is a principle in a DFM. So we have done idea generation, we have done feasibility studies, we have done rapid prototyping with form design, functional design, production design. Now, the outcome of rapid prototyping process is two: design specification and manufacturing specification. Don't confuse with performance specification. Performance specification is after feasibility studies. Performance specification is an input for rapid prototyping. Come out, you get design spec and manufacturing spec. You combine, you go and do the final test. Okay. So the rest you read from the diagram. Okay, the rest is just elaboration on the terms. Okay, I want to highlight this one. Design change, also known as engineering change order. When you go to work later, you will see they have a document called ECO. ECO means engineering changing orders. They want to change something, or in a technical drawing in your AutoCAD or SolidWorks class, there's a revision in the template. So there's a way of doing that. Sometimes they put in the orders number there. What is the serial number for that one? Okay. Okay, the rest you read. Okay, I think I think we stop here. Friday is your test. Your test. Next week we continue with chapter 7. Any question for your test? Anyone? Any question want to